In this screencast, I will demonstrate how Epsilon Simulink driver can be used to transform UML activity diagrams defined in Papyrus UML into executable Simulink models. So let's start with our UML diagram, or UML activity diagram. You can see how it consists of a root activity called UML to Simulink demo, and then three nested activities which are stereotyped as function. So function is a stereotype I have defined in this small profile over here, and which essentially allows me to attach expressions, so bodies, to these activities. So if we have a look at one of these function stereotyped activities, we have a look at its properties, then we can go to profile and then see our applied stereotype. Right, so what happens here is that this activity in its body specifies that the output is going to be the input, whatever the input is, multiplied by 2. By the same token, this activity multiplies its input by 3, and then this activity over here adds its two parameters to produce the output. Okay, so let's have a look at our transformation. This transformation in ETL, which is Epsilon's transformation language. I will just zoom in a little bit. Okay, so this transformation has a number of rules for transforming UML activities into Simulink subsystems if activities are not annotated as a function, or if activities are annotated as function, transform them into custom MATLAB functions. It creates ports both for input and for output, and then it links ports together in Simulink. Okay, so what I'm going to do is I'm going to run the transformation. First of all, I'm going to go through the run configuration. So this is our transformation here. This is the source of our transformation, or ETL file, and we want to run it against two models, one called UML, which is our UML model, the UML model I just showed you, and then against the Simulink model, which is our target model, what we want to generate. It doesn't exist so far, that's why we don't read it. Okay, so I can run the transformation, and you can see Simulink has popped up, and a new Simulink model has been generated. Unfortunately, Simulink doesn't provide an auto layout feature, so I will have to lay out this generated model by hand. So I've tidied up the model, and we can see how it mirrors the structure of the activity diagram. So we have one top-level subsystem. Going back to our diagram, this reflects the top-level activity. And then if I double-click into this subsystem, I can see three functions which reflect the three functions I have in the activity diagram. They have inputs and outputs, and also if I double-click on one, I can see the code we specified in the activity diagram. So the transformation also generates a number of dummy inputs in the form of constants, as well as a scope that will collect the output of the top-level activity so that we can monitor its evolution. So the two generated constants have a default value of 1, which means that if we run now this model, remember both of these will go into our into our subsystem. One will be consumed by the double function, so it will become 2. The other one will be consumed by the triple function, it will become 3, and when they are added up, they will result to 5, which is what will be recorded by our scope. So if I run the model, and open the scope, we can see that the value is 5. Now I will change this value from 1 to 2, which means that our result should now become 8. So if I run this again, the new value is 8. Alright, so I should clarify that the transformation is by no means complete. For example, it assumes that all inputs and all outputs are of type double, which is the default type in Simulink, but it can be trivially extended to support the other data types.